Right, y'all, how y'all doing? This is the problem. And it's based upon a cube, right? So we got a cube. And the diagonal from edge to opposite edge goes in the middle of the cube. All right? So the first thing we have is that this cube has sides of 1. So we're going to have to do 2 Pythagorean theorem problems. To get the diagonal that we want, the long diagonal, the space diagonal, because it goes into the third dimension, whereas a diagonal on the side of the cube can be put in a 2 dimension. So that's why they call it the space diagonal. Well, we've got to get the right triangle here that has a leg of 1, and this leg on the bottom is a diagonal on the side. So we need to get this 2-dimensional diagonal to get the 3-dimensional diagonal. And this 2-dimensional diagonal has 1s on the side. Okay? So I'm labeling this the first space diagonal, the first 2-dimensional diagonal, which I call x. All right, it's just the Pythagorean theorem because these are right triangles, so we'll solve this problem, which means this is the square root of 2. Okay, and now we can use that to solve for the first space diagonal. Well, looks like this pen is about done. I'll use it a little more. So notice what happens here. You get 1 plus 3, 2, so you get 3. So the square root of 3. Now there's a pattern that occurs with this, and you'll see the pattern after we do this a couple times. All right, now this might have been the tricky part, the interpretation. This space diagonal that we just calculated, the first space diagonal, is now the side of another cube. So these 1s were the original sides of the cube. That's now going to be root 3. So that's why I'm drawing this diagram, and notice that's why I drew it that way. We're going to do the same thing, but now we're going to find the second 2-dimensional diagonal and the second space diagonal. So we just replace this, this, and these 3. So these 3 are the root 3's. Okay, and then we're going to do the same thing again. So again, we got to find the second 2-dimensional diagonal. These are root 3's. Now, maybe you can do a little shortcut in your head, since you know that's going to be 3 plus 3, and then you take the square root of 6. I mean, that's what I would do. Okay. And so now we're going to do the same thing we did earlier. We're going to find the second space diagonal. And so we got the root 6 for the 2-dimensional diagonal, x sub 2. And we got the root 3 for the leg, d sub 1. Okay, so now we're finding d sub 2. Okay, so remember, you square a square root, it's eliminated because this will become root 6 times root 6, which is root 36, which is 6. So you could say these things cancel. It's not really what happens, but it's all good. Right? Now I'm going to leave it square root of 9. We know that's 3. All right, so let's do this one more time. So then we'll be able to see the pattern, and then we don't have to do this again. So now we're going to go to the third cube. And this cube now is going to use the sides as the second space diagonal. So this second space diagonal is going to be where these 1s are. Okay? So this is now going to be d sub 2. And then this is going to be the third two-dimensional diagonal. Let me write that better. And this is going to be the third space diagonal. And once we calculate this one, we'll notice a pattern, and then we can just use the pattern. Okay, so a very similar thing. We want to first find the two-dimensional diagonal, x sub 3. So we use the previous space diagonal from the second cube as the legs. So down here. And again, I'm just leaving it as root 9. We know that's 3. Alright, so 9 plus 9 is 18. So we add that. Now I'm not going to simplify that. Okay, so now we have the other leg in the right triangle that we're going to use to get the third space diagonal. And the other leg would be the second space diagonal. So we're going to use the root 9 and the root 18. D sub 3. Okay. Anybody see a pattern here? We just want to get the fifth space diagonal. Here's the first. Here's the second. Here's the third. Anybody see a pattern? What do you think you're doing? Right? Times 3. Times 3, times 3, times 3. So we just need the times 3 two more times, which would be times 9. I did this earlier, so I'm just making sure I didn't do a stupid mistake. You know how you all know I can make stupid mistakes sometimes. Right? And this would be 243, which we can simplify as 9 root 3. You could also think of it as this, right? Which you can change this into 9 times 3 times 9, right? So you got a 3 and you got a 3. 3 times 3 is 9. Anyway, that's it, y'all. This will be the last problem of the day that I gave you guys today. Not this one, but the one today. I'll explain that tomorrow. And I've got a good idea how to use Zoom, so we'll discuss that tomorrow, though.